Hello, nice to meet you. Yeah, I want to talk about migrations, and I kind of want to do that through a story about one of the more interesting migrations that I've been a part of at my time at Gearset. Tiny bit about me, I'm a software engineer, obviously. I work at Gearset, and I have done for about 7 years. Over that time, we've grown from about 7 people to over 200. As part of that, we've kind of needed to do quite a few migrations, both in our technology and how we organize our work and structure our team. Software engineering, I think, is kind of learning how not to do things by doing them wrong a lot of times. And any project that has kind of an interesting, sort of lasts an interesting amount of time, it has to survive all sorts of changes in technology, thinking, best practices, team structure, business context, user count, 1,000 other things. So if you can't reason about and pull off a migration or two, I think eventually you'll be dead in the water. So that's why I'm interested in migrations. So I guess this talk is two things. It's, like I said, a story about our React upgrade. We'll get into the weeds of how we did it, what was hard about it, how we got the rest of the team involved. And then we'll talk a little bit about what lessons I think we can apply about migrations in general, both from this story and from all of the other migrations that I've been a part of. So let's talk about React. To kick off, you need a little bit of context. You don't really need to know what Gearset does as a tool, but you do need to know that it's a web app. This is a list of the technologies that power most of what we do. It's not an exhaustive list, but it's kind of the bread and butter of our tech stack. Obviously, as you can see, there's no React. This is how things stood before we started the migration. If we zoom into that front end a little bit, the framework we were using for our front end was called Durandal. And if you haven't heard of that, I do not blame you. It's a pretty old framework at this point. Hasn't been actively developed since about 2016 or so. I just found out the other day that the documentation has gone offline, although it is still in the archived Git repo, so that's good. In terms of how it works, it's a really thin wrapper around these 3 other libraries, which you probably have heard of. It uses Knockout for all of its data binding between view models and the DOM. On top of that, it uses require.js and jQuery to kind of implement a component system so that you can have reusable chunks of functionality. And then it has all the other core bits you'd expect from a front-end framework, like a router that loads the correct module when you visit a certain URL, that sort of thing. But it's a really small layer on those libraries, basically. This is a really quick code sample. Don't worry about reading all of that. The vague structure is all I want to show you. So this is the component that renders the dropdown on the kind of bottom left. We've got a view model file right at the top and the HTML view at the bottom, and that references various values in the view model, and it binds the data to the dropdown element using Knockout. This is how you'd use that component. In another view in the HTML, you use this special widget data binding. You tell it what kind of widget you want. It's a front-end framework, same, but different. In terms of how we were shipping that code to production, there was very little build. We had some basic transpilation, but yeah, basically nothing apart from some linters, no bundling, no minification. What you write in the editor is very close to what gets shipped to production. And a common reaction when I used to tell people this was basically, why? You're like 20 frameworks behind. And yeah, I mean, this is the story of us doing that upgrade. So obviously it got to the point where this wasn't working for us anymore. But I think there's something to be said for old, boring tech stacks. And this has been said before, but I'm going to mount another small defense of old, boring things. This has a lot going for it. Firstly, it works, and it has done for a long time. And that's a big point in its favor. Obviously, it's not sufficient on its own. You could justify never changing anything at all with that argument. But the fact remains that it's been in place for 5+ years at this point, and it was occasionally an annoyance to be on an old tech stack, but we rarely felt that the development team was held back in delivering what we needed to deliver. Secondly, there's not many moving parts. There's no real build. Libraries and frameworks we're using, they aren't changing under our feet. They're just getting security updates and performance improvements. And that lack of moving parts makes problems really rare and easy to debug, basically. Durandal itself is a really small framework. The whole of its business logic is maybe 15 JavaScript files. a couple of those are chunky, there may be 1,000 files, but it's really feasible to get a good understanding of how it works in one day or a few hours. Another thing keeping us from upgrading was that we kept the front end pretty simple anyway. We tried to keep as much of our business logic in the back end as possible. That just means there's less benefit to upgrading. And finally, there's always that risk of picking the wrong new shiny thing, and JavaScript frameworks haven't historically had the best reputation for sticking around for the long haul. But you have to revisit your assumptions every now and again when things change. And if your assumptions have changed, maybe your conclusions should change. So what made us reevaluate? Well, firstly, yes, it works. But over time, things worked less and less well, particularly as the app grew. So we started to have performance issues on some pages, especially ones that had a lot of data to show. We traced that down to basically being Durandal's component system not being very clever. It's small, but it's not very smart about composition and updates to the DOM in particular, especially on page load. So we found basically that pages with too many components on them got slow, even if those components were super simple. And that started to drive bad behavior because we started to avoid splitting out components, even if we knew it would be a better structure, just to avoid the performance overhead, which is not an ideal place to be in. Those bad habits had an impact on how easy everything was to debug. And in addition, as the framework got older and fewer other people were using it, it was harder to turn on to the community for any help with framework issues. And eventually, as we found out, the documentation gets taken on offline. Another problem was security updates. When the project was kind of finally put into maintenance mode, we had to manually update the underlying libraries when security patches came out. That was manageable because it's a framework with a small footprint, but it was still an overhead. I touched on this already, but our philosophy remains the same with keeping the front end as thin as possible, but pushing our product forward started to put us in the position where we wanted to build richer front-end experiences, things like graph views with drag and drop movement of nodes, browsing of really large data sets, things like that. And those experiences were possible to build, but they were difficult, especially when we wanted to integrate new third-party libraries, which weren't designed to kind of slot into this legacy setup. And obviously that risk of picking the wrong thing to upgrade to is always present, but the longer something's been around for and the more popular it is, the more confidence you can usually have that it'll have a large community for kind of the foreseeable future. So React definitely felt like it was at that point in its adoption cycle when we started this. So really the summary is that all of these factors were moving in the direction where the return on investment was becoming more and more clear, and at some point we reached a tipping point. It was kind of worth the risk, it was worth the migration overhead, and the increased complexity in return for a better developer experience, lower maintenance, and ultimately a better customer experience. That's what we're really aiming for here. So at this point we've decided to migrate, but we need a plan of attack. I spent a lot of my time thinking about risk. A lot of the hard things in software engineering, I think, can be usefully framed in terms of managing risk. The risk of making the wrong decisions, the risk of breaking things, the risk of not understanding the full picture and building the wrong thing. So as a team lead, I think about how to manage that risk for my team and how we can keep momentum up without risking giving our customers a bad experience when we get things wrong. So again, I thought about this in terms of risk. What are the big risks here? There's a risk that we give our customers a bad experience. We don't want to stop delivering fixes, features, upgrades while we do this work. We don't want, basically the world can't stop while we do this work. There's a risk we don't finish the job. If we get 80% of the way through, for example, and we stop when we've done all the easy bits, we end up with the worst of both worlds kind of forever, which is another bad place to be in. And then there's also a risk that we tangle the code base in the process. If we want to end up with a more maintainable code base at the end of this that helps us move faster, if we mangle everything in the name of finishing the migration, then we'll end up in a worse position than when we started. And there's always that risk of breaking absolutely everything, but I guess that's omnipresent as a software engineer. So how do we mitigate all of these risks? These are the main tools I reach for when I'm thinking about something risky and how to reduce that risk. So practice first. Practice makes perfect. You want to make that practice as representative as possible. You want to make sure the consequences of failure are low. A good way of doing that is to make it routine. The more often you do something, the less scary it is. And if you make it routine, then you can iterate on the process. And over time, your process will be kind of battle tested, and it will be better than you could have designed it in the first place. So the first three here on this slide, they're pretty universal. Think of deployments to production. How do we make those low risk? We have a staging environment where we can practice each release. It's as close as possible to the real world. We release often. We make it routine. Multiple times a day if we can manage it. We iterate on that release process. If anything goes wrong, we examine it and we say, what could we do to make sure that can't happen again, or it's unlikely to happen again. You can probably even apply this to airline safety. I'm pretty sure they practice flying the new plane before they put passengers in it. I'm not an engineer of that type. The final point here is to front load the unknowns, and that's a little bit different. That's not about the risk of breaking things. That's about the risk of building the wrong thing based on the incorrect assumptions. So by thinking about what assumptions we're making and what we're least sure about in that list of assumptions, if we can explore those assumptions right at the start, then we can maybe save ourselves a lot of time going down dead ends. So these are the big risks that we identified. How can we apply those strategies I just talked about? Well, actually, pretty much all of the things that I said can be achieved by doing it a little bit at a time and by picking the right bits to do first. We can kind of front load the risk, and we can practice by picking the right bits to start with, and we can do more and more chunks, and the process will become routine and low risk. That's the plan. So we've already written off the all-at-once approach. Another approach might be go one page at a time. So essentially by doing this, you can silo the old world and the new world entirely. Each new page load might be on the old framework, or it might be on the new framework. Ideally, the user doesn't notice, and you can have a nice, clean separation between the two stacks. That doesn't really work for us because we have a single-page app. Navigating to a new page doesn't actually reload the browser page. We considered modifying our existing app so that it did. It was kind of tricky, though, and it was a risky task in and of itself, and we're trying to reduce the risk here. There's also a reason we don't do that. It helps us build a snappier experience. So we're left with one component at a time, and the idea here is that we find a way to mix and match React and Durandal components on the same page, and then we slowly replace the Durandal ones with React ones. So you can do this a couple of ways. You can go top-down, so you can replace the top-level app component with a React one, but keep everything inside it as legacy, and then you can slowly replace downwards until you've got no legacy left. Or you can go bottom-up. You can find a way to run React components inside the legacy ones, and you can start replacing upwards, basically, until nothing's left. So what's easiest here? I think you could argue either way, really, but we settled on bottom-up in the end, so replacing the leaf nodes first. There's a couple of reasons for that. Firstly, it's really easy to run a React component as its own self-contained thing. You just give it a DOM container to run in. Secondly, our top-level components have ended up with quite a lot of state, partly as a result of that thing I talked about not splitting out components when we could. So those top-level components are the riskier ones to migrate. And that's not really the risk that we're interested in de-risking. We can de-risk the more important risks. Can we run these frameworks side by side at all? What does it look like in practice? Before spending too much time on the problems that we know can be solved, like how do we write this in React? How do we store the state once we're in the React world? All that sort of stuff. It's worth saying that we could have done a mix, top-down and bottom-up. We decided for the start of our migration to do strict bottom-up. By that, I mean we don't allow legacy components inside new React components. There's a few reasons to consider doing that. It's one less problem to solve. We only had to know how to run a React component inside Durandal, not vice versa. It gives us a nice clean separation, and you have a clear sense of how much of the app is migrated, because you know that once the top-level node of a page is in React, the whole page is in React. We can't cheat by not migrating tricky components. It does have a downside, which is that we might have to maintain 2 copies of commonly used components, so buttons and things like that, and keep them in sync. But yeah, everything has downsides. So we have our plan. Now for the hard bit. So what's hard here? Really, it's the interface between those 2 frameworks. And our first attempt was just to drop the React components in. And this is what that looked like. This is just a standard Durandal component. There's nothing special happening, apart from right at the bottom in the binding complete handler. That function will be called when our component's DOM is fully loaded. We just made sure to put a container in the DOM where we can mount some React. And then we just tell React DOM to render our component in there. So that's pretty simple, pretty decent. And here's the React component. It's just a bog standard React component. That's straight from the React docs. There's one small detail which you might notice if you have really keen eyes. The module format here is AMD. And if you haven't heard about the checkered past of JavaScript module formats, congratulations. Here's a quick and almost certainly incorrect summary. In the good old days, JavaScript was for mouse cursor trails and drop-down navigation. That was about it, and everything was global. And a little while later, people thought, well, that's not really ideal. Everything can trample on everything else, but the only tool really for making anything private was a function closure. So then came along functions which immediately executed themselves as a way of hiding state from the global scope. And then Node.js came along, and they thought, well, we probably do need a real module format for this, and they invented CommonJS. And that works pretty nicely, but it does have the downside of being completely synchronous. So when you load a dependency, the world stops while you load it and run all of its dependencies. That's fine maybe for server code. Sometimes in the browser that's not ideal. So then Require.js came along and said, we're sorting out this mess for the browser. They invented asynchronous module definition, which is what you saw in the last slide. You still have this problem with knowing which of these things to use and getting compatibility with between everything. So ES modules came along, and that's like an actual standard with native browser support, and that's supposed to solve all our problems. And I don't know, maybe it will. And then UMD's hanging out in the corner, and that's not really a format, but it's kind of a way of writing modules so that people can read them as either CommonJS or AMD. So it's really simple, right? And we're all going to use ES modules soon. I don't know. Anyway, look, the point is, Durandal uses Require.js, and Require.js speaks AMD. But AMD is old and weird, and nobody likes it anymore. So, yes, we can drop in our React components as AMD modules, but we started to run into a few problems. There's a minor problem, which is that third-party tooling gets a bit confused, so editors start to struggle to do things like find usage and that sort of thing. That's annoying, but it's not the most important issue. The most important issue is that third-party components are no longer shipped as AMD in the React ecosystem in general, and that makes it really hard to directly integrate them in some cases without a lot of faff. And finally, once we're done, even if we succeed at this, we'll have everything in this slightly outdated module format, and things will just be slightly weird. So we decided in the end that we needed to revisit our minimal build. We need to get ourselves a bundler, and a bundler gives you a bunch of stuff, and it's all on that slide, but really what we're interested in is that ability to mix and match module types, so that we just don't have to care about this problem anymore. So the most popular and well-supported bundler is Webpack. We just drop it in, right? It's the default solution, it has a massive community, it has countless plugins, it's endlessly configurable. We just found the new hard bit. Why is this hard? Webpack is a static bundler. What do I mean by that? Well, I mean that the dependency resolution is static. So it takes one or more entry points in your code, and then it analyzes your dependency tree by following all of the imports. So every import it finds, it parses it, it replaces it with some Webpack magic, and then it bundles everything together at the end via whatever plugins, loaders, whatever. So that means it needs to know at build time how to follow all of your dependencies, which sounds like a pretty reasonable request, right? It is a reasonable request, but it's not how Durandal works. Durandal uses Require.js, like I've said, but in front of that, it actually has a layer that lets you configure how the framework finds your component files. And that's a pretty handy feature, especially if you don't have a front-end build, which most people didn't when Durandal was written. It lets you kind of configure the location of the files on your server however you want without having to do any transforms in your build. But it causes problems for Webpack because it can't follow that custom arbitrary runtime routing, even if you're not actually using that functionality, which we weren't. And we thought about quite a few solutions for this, but in the end, we ended up writing a patch for Durandal for this. We thought about writing a custom loader or a plugin for Webpack, but this actually turned out easier for a few reasons. First, when we finish the migration, we can safely delete that workaround with 100% confidence because we're deleting Durandal anyway. Secondly, Durandal is easier to understand than Webpack by an order of magnitude, I would say. We're not actually using that custom module resolution that's the problem, so it should be reasonably straightforward to patch it out. And Durandal no longer gets updates, so we won't get any upstream updates that conflict with our patch. There shouldn't be much maintenance overhead on that patch. So the main problem here is that if we're patching out the current way that Durandal loads dependencies, we need to give it a replacement so it can load the right thing at the right time. At the same time, Webpack needs to be able to build a dependency tree of everything. I always like to start with a stupid solution, and a stupid solution here is to import every single component right at the top of our app. So we have a big file called widget registry. A widget is what Durandal calls a component, and it has a list of every widget, and Webpack can use that to find everything and include it in the build. And then we can use that file to go load those dependencies at runtime in Durandal. When Durandal would have previously gone to the network to get a dependency, it can just go to that file and find it in a dictionary. So this is a little snippet of what the widget registry looks like. It's much bigger than that. But it's just a dictionary mapping from widget name to the module ID for that widget. That's it. So that solves the problem of Webpack finding everything and putting it in the build. But we still need Durandal to be able to load that at runtime. So this is a very rough sketch of the logic of how Durandal would load a widget before this change for our patch. So whenever the component lifecycle wants to load a new component, first it goes to the custom logic to get the module ID. That's that custom translation layer. In our case, it just returns the path you gave it. Then it takes that module ID and it asks Durandal.system to instantiate this module. Durandal goes to require.js, and require.js returns one from the network, or maybe from its cache. And here's how we changed it. So we modified get module ID, and we actually made it go to our widget registry, and instead of returning a string path for a module, it actually just returns the module itself, the whole thing. And then the component lifecycle, because it's JavaScript, very happily just adds that to Durandal system as if it's a module ID. But we just patched Durandal.system to just do the instantiation logic it needs on whatever you pass it and return it back. It never needs to go to require.js at all. There's one other main bit I haven't shown you, which is that we also needed to make the dependency between the view model file and its corresponding HTML view file. That had to be made explicit as well for Webpack. It's more of the same sort of stuff, so I'm going to skip over it. The point here is that there's a very small amount of code that needed updating, really. So this is surprisingly easy, and it does actually work, which was absolutely flabbergasting when I first fired up the app. There are some downsides. We have this big lists of components. We'll have to build those, and we'll have to update them whenever the list changes. Secondly, we're lying to Webpack. It doesn't know the true dependency tree here. That means it won't be possible to kind of split the final code bundle. We'll have to load all of the code on first load of any page. The first of these is a bit gross, but it's okay. It's temporary while we do the migration. It's pretty easy to automate building the big list. The biggest concern for me was the performance of having to load our entire front-end code base on page load, no matter what page you're on. We said at the start that one of our main objectives was not to give our customers a worse experience during the migration. I don't know about you, but my gut said that this was a bad idea and that first load times would be way, way worse. But as with everything performance-based, you should measure it to see if it's an actual problem. So this is a graph of before and after this change, how much JavaScript is loaded to just load the main homepage of the app. So before the change, 1.1 megabytes of JavaScript gets loaded, and after was 1.4 megabytes, and that's our entire front-end code base, minus a few third-party libraries that we managed to split out, which surprised me. How can it be such a small change? Well, really, this is a lesson in the power of Gearset. So previously, we were loading each component as a separate network request, and that meant that each one had its own separate compression applied. But when we bundle everything together, we can compress everything, the whole bundle, in one go. And that makes a massive difference, even after minification, which is also being applied in the second case. So there's some hidden extra overhead here, obviously. Size isn't everything. The browser's going to have to do a lot more work because there's a lot more meaningful content here. But we found in practice that was balanced by another saving, which is you don't have to load all your dependencies in sequence anymore. Before, you'd have to load one component to even find out what its dependencies are. So there's a whole network round trip on every layer of dependencies. By eliminating that, we save a lot of time. So this is actually what we eventually went to production with. In aggregate, we found that after we released first page loads for real customers, they were pretty much unchanged on average for any metric that we looked at, and particularly first page interactivity. And it's worth saying that after this, all subsequent pages are much faster because there's no network request at all. We've got that code downloaded already. So you might be forgiven for complaining you thought this talk was about React. Don't worry, it is. We've got Webpack, we've solved all our problems. It's really easy to drop in new React components. So now we can go back to this example where we just dropped React in. This is still an AMD module, but Webpack doesn't mind that as long as the references are static, not dynamic, which they are in this case. And the difference now is that the React component itself can be in whatever format we want. And we can import any third-party components that are in any format they've chosen as well. There's another tricky part here, which is managing the state across the framework boundary. So React out of the box uses props to pass values down to children, and hooks for state and side effect type things. Durandal uses knockout, which has very similar concepts. Knockout calls those computeds and observables. Here's an example. The main point here is that they're very similar. React is a little bit more magical in re-rendering whenever anything changes. In Knockout, you have to explicitly make things observable, and then you can create these computed values out of the observables. Once you've done that, everything updates in response to any state changes to the observables. So if we've got observables in a parent component, and we want to pass those down as props to a child React component, what do we do? A naive approach is to do this. You just need to call the observable as a function to read its value. So this should work, right? We're just passing in the observable as a prop, and then when we render, we just call it to get the value. And that will work on first page load. But if the observable changes, a render won't be triggered. React doesn't know that the underlying value has changed. It's still got the same function pointer as a prop. So if a render happens to run for another reason, it will update. And that might end up with a situation where it kind of almost works, but it's a little bit buggy. If you want to do this properly, you have to subscribe to the observable and update your own React state whenever it changes to prompt React to re-render. That works. It's a little bit clunky. It's also pretty easy to get wrong. So for that, we established a few rules. Firstly, new components must be in React. For a while, we only had that rule, and that allowed us to kind of keep momentum up on shipping features, whilst we built up some institutional knowledge on all of those patterns from the previous slide, basically. It kept the risk low while we were learning how to navigate the new world, and it introduced the team kind of slowly to this new world. And now we're pushing ahead with the second rule. If you touch something old, you upgrade it. If that's not practical, sometimes it's not, you identify at least one thing that you can do to get us closer, and you do that. And eventually we'll probably have to add some third rule aimed at mopping up the long tail of rarely touched components that we rarely change. We're not quite there yet. So we're pretty happy at this point. It went pretty well so far. I'm fairly confident it will continue to. We'll see. What can we learn? Well, this isn't the first time we've done a migration in our tech stack. This is a sample of all the ones I could remember. There's probably more that I've forgotten and more that have started since I wrote this slide. You might notice we migrate towards Postgres a lot. If you want to hear a bit more about that, you should go to Dave's talk at 5:15. The ones down the bottom are the ones that are kind of in various states of progress, from very well underway to just getting started. The vast majority of these went very smoothly. So I kind of had to think about what all the best migrations we've done, what do they have in common, and what was missing from the ones that were slightly rockier. I think number one, we always do the smallest change we can in each increment. And that applies across pretty much everything we do, but I think it's even more important for things like this. If something goes wrong, hopefully it's just something small because you only changed a small thing. Number two, we always have a rollback plan, so something always goes wrong, so you have to plan for it. Mostly this is handled by our blue-green release process, so 99% of the time we can just instantly switch back to an old, known good version of the app. Sometimes this is hard, usually because it involves data, or because it involves some sort of caching state. So, for example, if the user's already downloaded the new broken version of the front end, what happens then? It's still possible to provide a good experience, but sometimes it's a little bit harder. Like I've said a few times, we like to front load the risk, and that means doing the refactors up front. Make the change easy before you make the easy change, and that's why we spent half an hour talking about Webpack today. I think this one's even more powerful when you can have a change like this where a small team can really dig deep into making the change easy and really get their heads into it before letting the whole team go on the easy change once you've actually made that refactor yourself, and they don't have to worry about all of the complexity that you've kind of hidden for them. Number four, if everyone needs to be bought in to make this happen, make it easy for them. Establish patterns, establish rules, make sure they're clear on what's happening. Be open to amending those patterns and those rules if it makes sense to you. But just make it easy. And in the same vein, it really needs to be simple to drop in the new tech. Making the interface low friction using patterns and adapters makes it really easy to do the right thing and really hard to do the wrong thing, and that lowers the risk. It's also important to keep the boundary clear between the new world and the old world, and in particular, the new world should know as little as possible about the old world. If one world has to know about the other, the old world should know about the new world. That way, when you're finished, you make sure you've actually purged all of the downsides of the old system you're trying to get rid of. Finally, number six, make it easy to see how much of the job is done. That makes it so much easier to finish the job. If you can't see where you are, it's really easy to get demotivated and lose steam. If you can see progress, you can keep the momentum up. I've heard some companies take this a step further and kind of give each team a percentage done for each migration they're doing so that they can have some competition between teams. We haven't tried that out ourselves. I don't think our boundaries of code ownership are maybe quite clear enough to do that, but if you have that, then I think that's an interesting thing that could maybe work. So, thanks so much for your time. I hope this was interesting and or useful. I'd love your feedback or your questions. I'm drop off, and you can give me questions offline, but I'll be on the booth over there, so catch me or feel free to email me. Thanks very much.